Ladies and gentlemen, welcome to a third video on the Fivefold Sun. The first video was an introductory one. The second video dealt with the length of the Schwaber cycle overall. Now today we are going to deal with the legs of the solar cycle. The rise leg, which is also called the ascending phase, and the fall leg, which is also called the descending phase of the solar cycle. The bounds of the cycle, of course, are the first minimum epoch and the last minimum epoch, and the apex of the cycle is the maximum epoch. So the rise leg starts with the minimum and ends with the maximum epoch, and the fall leg extends from the maximum epoch to the minimum epoch. This matter is treated in section 2 of part 1 in the book The Fivefold Sun. We are today October 4th of the year 2018, and this is about a year again after the book was filed at the Bibliothèque Nationale de France in late 2017. The topic of section 2 again is the rise leg and the fall leg, their lengths and the ratios of their lengths. We start with the results that were published in the literature about the length of the legs of the solar cycle. The ratios actually have been rarely explicitly computed and cited in solar physics literature, but they are computed here. And then we discuss, we introduce a new determination of the fall-rise length ratio. We will do this from two procedures. One is to use to arrive at a fall length ratio from consideration of the mean lengths and mean rise lengths and mean fall lengths across all cycles. And in the second procedure, instead, we will use in each individual cycle the length of the rise leg and compare with the length of the fall leg and in absolute terms, and arrive for each individual cycle at an individual fall over rise ratio. Which then will allow from the several individual ratios to arrive at a central value for this ratio. In conclusion, we should arrive at robust central values for the absolute lengths of each of the legs, and also to a robust estimate, rather precise estimate of the length ratio between these two legs, as well, of course, as the ratio between each of the legs and the overall cycle length. This is a table of estimates of leg lengths for the solar cycle published in the literature since Wolf in 1890. Wolf in 1890 estimated the mean rise length as 5.1 years and estimated the mean fall length at 6.05 years. As you can see, the fall length is longer. There is not any investigator who suggested that the fall length would not be longer than the rise length as a mean. These, of course, are not central values, they are means. And we saw in a previous video lecture that in the case of the solar cycle, there may be significant variance between mean and central tendency represented by a median or a mode or a peak frequency. We can see that the ratio between these two lengths is slightly less than 1.2, involves data in 1890. But the next few authors arrived rather at a ratio of at least of about 1.4. This is true until 1964 with Bray and Loughead, their famous book on sunspots, where they found 144 after Abeti, who found the same value a few years before, Bruat in France in 1931, 1.41. These ratios are less than 1.5, but they are much more than Wolf's original 1.2 estimate. These, again, are ratios that are calculated in my work, the Fivefold Sun, but were not usually explicitly cited by the relevant, the respective authors. Now, after 1964, we see a jump in the implicit ratios for the lengths of the legs found by the authors who considered these quantities. You see that apart from the quite outlying value found on the basis of identical rounded estimates by Wilson and by Hathaway, we have a value of 1.5 or more for the ratio of the fall over rise leg lengths since 1996. So this amounts to a rising trend in the estimate. This is one of the beauties of meta-analysis, that we can see a trend in over time, especially at a centennial, at a secular scale, that is interesting to note. And we see mounting evidence that the ratio is based on the most recent studies, which of course rely on the longest body of evidence. It might be more than 1.5. This table now is the basis, one of the two bases of the original investigation of the matter that is proposed in the Fivefold Sun. And it is the set of all the extremum epochs of all cycles for which the extremum epochs can be precisely dated. Unfortunately, these time span starts as late as 1810, because before 1810 we do not find in original data or in investigations published in the literature enough evidence for a precise timing of the epoch of the maximum of a solar cycle. So starting in 1810, we have the precise maximum epochs estimated, and in this case we can till present determine what is the length of the rise leg and of the fall leg of each cycle. These quantities are then noted in the last column here. For example, for this cycle number 17, the fall length is 6.5 and the rise leg is 3.8, plus more decimal places which are not warranted by the precision of the original data. We have now the possibility of comparing the ratios of fall length and rise leg length in the several statistical series which were listed on the preceding table, and we will arrive, considering the various series, the various composed series that can be made out of these individual series, various estimates of the ratio for the fall over rise leg length in each cycle, from the first one under consideration to the 18th one or 17th one under consideration, which is the entire set of cycles for which a maximum is well known, and thus the leg lengths are well known. And we can see that when we sort out these ratios in a decreasing order in each of these columns, we arrive at two median values which have to be averaged out because of the even number of quantities to arrive at a central median value. And we can see that there is a variation between about 1.4 as the floor of the found ratio, to less than 1.7 as the ceiling of the found ratios. For instance, here 1.714, but it has to be averaged out with the other median of the even number of variables, of quantities. So 1.7 is really the ceiling in this list of quantities of median values. And if we look at now each of these values, we will see in the next page that they average out at in this range to a central median value of about 1.635, ranging from 161 to 167. This is the median value of the fall-rise length ratio of the Schwabe cycle as found from this method. The mean is lower and is only about 1.56. And the mode, as in the case of the overall length of the Schwabe cycle, is very close to the median and is from 1.60 to 1.62, ratio of the fall over rise length of the solar cycle. The new revised data of the relative sunspot number by SIDC CIRSO in 2014 were taken into consideration exceptionally here as a sensitivity analysis and as a control. And we can see that it is now a narrower range, which should be perhaps retained as the end result from 160 to 163 instead of from 161 to 167 for the median value, which is our preferred robust statistic for a central value. We then try to arrive at absolute lengths in years for the characteristic lengths of each leg of the Schwabe cycle based on two cases. In one case we retain 161 as a true ratio. In the other case we retain 162 as the true ratio. This amounts to a sensitivity analysis, of which I show today in this video only the case for 1.62. The inferred lengths of the cycle legs are, for instance, for a cycle of 10.615 year, which is the central value that was retained for 5 digits in the previous section in which we estimated the characteristic central value of the length of the overall solar cycle. then the leg lengths are for the rise leg 4.052 years, and for the fall leg 6.563 years. You see small variation in a case, again, only for 1.62 ratio, longer overall length of 10.65 or a shorter overall length, but the variations are really fewer than a month or so. So the provisional estimated central value for the rise and the central value for the fall lengths, with a central value length again of overall length of 10.615 years, and for a fall rise central value ratio between 161 and 162, i.e. 1615, they would be 4.059 years, and in the fall 6.556 years. This of course amounts to this total by construction. We now turn to the second procedure that was introduced here to arrive at a robust determination of the characteristic ratio between the rise leg and the fall leg lengths in the solar cycle, and their absolute values. And this is from consideration in each cycle of the length of the rise and fall leg as observed, which should allow us then to calculate a ratio for each cycle and then look at the several ratios. From consideration of the leg lengths of individual cycles, we arrive at a slightly different result, but within uncertainties it is almost identical to what was found with the previous method, 4.069 years for the rise length, 6.546 years for the fall length. When we standardize the cycle length to a standard of 10.615 years. So the fall over rise ratio of the found median leg length values amounts to 1.61, rounded from 1.609. When we consider now a combination of the results from the two procedures, we have the following suggested central values for the observed, of course, lengths of the two legs of the solar cycle. For the rise length, 4.065 years, and for the fall length 6.550 years. This is this is very close to some of the published estimates that were cited in the first page of this video lecture, and this yields a fall over rise ratio of 1.611, whereas the cycle over fall ratio is about 1.612. Two observations, two remarks are worthy here about the stability over time of the legs lengths about these central quantities. The fall legs length is remarkably stable. You see the average historical length of this leg since 1800 has been 6.56 years. And the central value we estimate here, which is not a mean or average, but a median, it's 6.55 years, so it is extremely close. There are very few cycles in which the fall leg departed significantly from these central values, and this is in sharp contrast with the behavior of the rise leg, which instead has had a quite variable length over time. It has been highlighted mostly by the Zurich researcher Max Waldmeier that there are very different cycle rise leg lengths in the history of the solar cycle. Waldmeier was able to elaborate on this and formulate a number of laws which are more or less well verified and have proved to be able of predicting cycles after the time Waldmeier studied this phenomenon in the 1940s mostly. You see the average of the rise leg has only been 4.4, has been as high as 4.4 years in the last 200 years, compared to only 4.06 years as its central value. So this is remarkable and is enigmatic, and it is one of the main pieces of main findings of the Fivefold Sun project, for which I have no explanation, and from which I was not able to infer any further useful insight. And I encourage researchers to look into this mystery. Note now that the found ratios are in slightly different proportions, 1:6:1 and 1:6:2 for the fall over rise length and for the overall cycle over fall length. But this is almost identical, so it is almost a unique proportion applying to the two ratios. If you use any other combination of lengths, you will have, of course, the two so defined ratios departing sharply. So there is just one mathematical expression and one ratio value defined by this expression, for which superposition of exactly the same ratios for the two entities is verified, and this is this expression amounting to 1.680 etc., which is known today as a golden ratio, but should really be called, as it was initially named by in Euclides and other Greeks, the mean and extreme ratio. This is the main finding and the final finding of section 2 in the Fivefold Sun. I thank you for your attention.